So we're going to talk about dividing fractions. Now the purpose of this video is to not just in general talk about dividing fractions, but to particularly make sense of, understand, how does that whole keep it, change it, flip it algorithm or procedure or rule make sense? So remember, that's the goal here. There's other ways that you can divide fractions. You can draw pictures, there's different algorithms, but the purpose of this particular video is to make sense of this keep it, change it, flip it idea. Now to do that, you first have to make sense of this. So here's the situation, just metaphorically speaking, to help you visualize what's happening here. Suppose you have 1 cup of flour. How many scoops of this do I need in order to make 1 cup of flour? Well, if you have a 1 cup scoop, it's only going to take 1 scoop to make 1 cup. But what if you don't have this? What if all you can find is a half a cup? So in order to scoop in 1 full cup of flour, you're going to have to fill this once, fill this twice. So the number of scoops that I'm going to need of this half a cup scoop to make 1 full cup of flour is 2. Now what I want you to see here is this. If the size of the scoop gets cut in half, then I'm going to need twice as many. 2 is twice as big as 1. I'm going to need twice as many scoops in order to get to that 1 full cup. Now likewise here, what if all you can find is a 1/3 cup measuring cup? You still want to make 1 cup in my metaphorical world here. You still want to make 1 cup of flour. Well, how many 1/3 is it going to take to make 1 cup? I would need 1, I would need 2, I would need 3 of those scoops. Now what if, in this metaphorical world, what if I had a 2/3 cup? Now this 2/3 cup is twice as big as this 1/3 cup. Remember, that's what this 2/3 means. This means 2 copies of 1/3. So 2/3 of a cup is twice as big as this. So every time I fill this up, I'm going to have twice as much flour that I had here. So I fill this up once, that'll fill this up 2/3 of the way. But then I will only need to fill this up a half of an amount again, because half of 2/3 is 1/3. So 2/3, and then another half of this fills it up. So I would need 1.5 of these. So look what happens. If you double the size of the scoop, you need half as many scoops. Or if you half the size of the scoop, you need twice as many scoops. You should be able to see the proportion either way. If you make the scoop twice as big, half as many scoops. If you make the scoop twice as big, I change that, make the scoop half as big, twice as many scoops. So half as big, twice as big. Twice as big, half as big. So now notice these 2 columns. The one is the size of the scoop. The second is how many scoops do we need. Kind of sort that through in your head. Here's one more. Suppose all you can find is the 1/4 of a cup. How many 1/4 of a cups is it going to take you to fill up this cup? You would need 1/4 of the way, 2 half the way, 3 3/4 of the way, 4. You would need 4 scoops of the 1/4 cup to fill up the cup. Now, what if you did this one? You tripled the size of the scoop. Can you imagine this? If I filled this up once, it would fill it up to about here. And then if I filled this up only a 1/4 of a way, a 1/3 of a way, I would get that last 1/4 in there. So if you triple the size of the scoop, then I would need 1 of these, and then another 1/3 of those to fill this up. I would need 1 1/3. I would need 4/3. So notice, if you triple the size of the scoop, you 1/3. You divide by 3, you 1/3 the number of scoops. So in general, I didn't draw this one, because I don't even think it exists. At least not at my house. But imagine there was such a thing as a 1/11th cup. How many 1/11th cups would it take to fill this up? 11. What if you triple the size of the cup? You would need 1/3 as many. 1/3 of 11. Divide by 3. You would need 11/3. So the idea is, here, double the size of the scoop, half as many scoops. Triple the size of the scoop, a third as many scoops. Or let me just make this even something like 5/11ths. 11 of these fill this up. If you 5 times the size of the cup, then you're going to need 1/5 as many of those scoops. Now, that's the first thing. You kind of have to get that idea of the size of the scoop and how many scoops. But now watch this. What if instead of making 1 cup, you want to make 4 cups? Well, if you got to make 4 cups, you're going to need 4 of these to make 4 cups, of course. You're going to need 4 of these. Now, how many of these am I going to need to make 4 cups? Well, remember, 2 of them made 1 cup. 2 again would make 2 cups. 2 again would make 3 cups. 2 again, I'm going to have to do that 4 times because that only makes 1 cup. So doing that 4 times, I would need 8 of those scoops. Likewise here, 3 of these makes 1 cup. If I have to do that 4 times 3, I need 12 of those. If I have to do this to make 1.5 of these to make 1 cup, 4 times that. Now, you know how I like how much I like improper fractions. What if we called this, instead of 1.5, what if we called it 3/2? So 3/2, 1.5 of these makes a full cup. If I need to do that 4 times, 4 times of that, 4 times 1.5, 4 times 3/2 would be 12/2, otherwise known as 6. 4 of those makes a cup. If I have to do that 4 times, 16. 4/3, 1 1/3 of these makes a cup. If I have to do that 4 times 4/3 is 16/3. 16/3, 5 1/3 if you like. 11 of these makes a cup. If I have to do that 4 times, 11/5 of these makes a cup. If I have to do that 4 times. So that second column is, if you multiply the amount of flour needed by a factor of 4, then you're going to have to multiply the number of scoops by a factor of 4. So sometimes times 4 times 4 times 4 times 4, but sometimes it's this idea of doubling means halving. 3 times means 1/3. 5 times means 1/5. And you got to kind of keep track of which thing we're thinking about, the number of scoops or how much flour do we need in the end. So sort that out. Now, how does that apply to our division of fractions idea? Here's how it applies. So suppose you had 7 divided by 2/5. Here's how I think about it. That's kind of hard. So I'm going to break it down and build up to the hard problem by starting with an easy problem. Instead of 7, I'm going to start with 1. Instead of 2/5, I'm going to start with 1/5. Now, what does 1 divided by 1/5 mean? It means how many 1/5s are in one whole? 5 1/5s are in one whole. That's what a 1/5 is. A 1/5 is what you get if you take a whole, cut it up into 5 equal parts. So how many 1/5s does it take to make a whole? 5. All right, but look, we don't have 1/5, we have 2/5. So how many 2/5s does it take to make a whole? So if you double the size of the scoop from 1/5 to 2/5, if you double the size of the scoop, you're going to need half as many scoops. Half of 5. Now I'm going to stick with the improper fractions here, I hope you don't mind. But certainly in your head, if you're thinking half of 5 is 2.5 as a mixed number, cool. But stick with my improper fraction here. So double the size of the scoop, half as many. Cut it in half, divide it by 2. But we don't have 1, we have 7. So if the amount of flour you need is 7 times as much, then you're going to need 7 times as many scoops. And yeah, I know 7 times 5/2 is 35/2. Because what 7 times 5/2 says is 7 copies of 5/2. Can you imagine? 5/2, then another 5/2, that'd be 10/2. Another 5/2, 15, 20, 25, 30, 35. You got 35 of those 1/2s. Now the reason I leave it like this is because I want you to see, keep it, change it. Now it's not that we want our kids to learn the algorithm and then go backwards and figure out why. I actually want them to just think through the reasoning here, and then let them figure out, keep it, change it, flip it. Let's do another one. 1/3 divided by 3/4. How many 3/4 are in 1/3? Hey, first of all, think about that. 3/4. Do you have it in your head? Take a whole, say, circle, cut it up into 4 equal parts. Imagine 3 of those parts, 3/4. How many of those 3/4 are in 1/3? Take a whole, cut it up into 3 equal parts. Imagine just 1/3. 3/4 is much bigger than 1/3. So how many 3/4 are in 1/3? Not even one. A part of that. Let's see what part. So here's how I would do it. This is too hard. I'm going to start with 1. That's too hard. I'm going to do 1/4. I'm always going to start with 1 whole divided by the unit fraction. 1/4, 1/5, 1/6, whatever. How many 1/4 are in 1? Okay, but it's 3/4, so let's move down and say 3/4. So the 1/4 now will get multiplied by 3, so we have 3/4. You've tripled the size of the scoop. If you triple the size of the scoop, you need 1/3 as many scoops, so divide by 3. 1/3 as many. But we don't have 1, we have 1/3. So imagine, you don't need a full cup of flour. You only need 1/3 of a cup of flour. So if the amount of flour is 1/3 as much, then we need 1/3 as much scoops, or 1/3 as many scoops. So I need 1/3 of that. Oh yeah, I know that comes out to be 4/9, but we want to see it as, if you take 1/3 as much flour, you need 1/3 as many scoops. And so keep it, change it, flip it. And now, does the 4/9 make sense? Remember, the original problem was how many 3/4 are in 1/3? Not even one. Turns out to be 4/9 of a 3/4 is in 1/3. Maybe it helps put the answer up here. This comes out to be 4/9. 4/9 of a copy of 3/4 will fit into 1/3. Just one more kind of messy one, just in case, but I have to be honest, there comes a point when you know the algorithm, use it. You don't need to always reason through this. It's sort of like that day where I wanted you to package and unpackage. So right now we're kind of looking at the unpackaging of the division algorithm, but at some point we package it and we use it. So shortcut it whenever you want. But just to practice the reasoning one more time, how many 3/7 are in 9/8? Maybe you want to even get that in your head. 3/7. Take a whole, cut it up into 7 equal parts. Imagine 3 of those parts, 3 1/7. 9/8. Take a whole, cut it up into 8 equal parts. Imagine 9 of those. So you have more than a whole. How many 3/7 fit in 9/8? A couple, 3. I don't know, we'll see. That's too hard. 3/7, that's too hard. So I'm going to start with 1 divided by the unit fraction. 1 divided by 1/7. How many 1/7 are in 1? 7. That's what a 1/7 is. Take a whole, cut it up into 7 equal parts. One of those parts is a 1/7. So 7 1/7 make a whole. But we don't have 1/7, we have 3/7. So I've tripled the size of the scoop, you could say, from 1/7 to 3/7. And if you triple the size of the scoop, then you'll need 1/3 divided by 3. 1/3 as many scoops. But we don't have 1, we have 9/8. So if you multiply the 1 by 9/8, you actually need 9/8 of a cup. So that 1 got scaled up by a factor, got multiplied by a 9/8. So if you need 9/8 as much flour, you're going to need 9/8 as many scoops. And I hope you see that. That was like we did over here. Times 4, times 7, times 1/3, times 9/8. Keep it, change it, flip it. So how many 3/7 are in 9/8? 63 24ths. I think you can simplify that. Both of these are divisible by 3. 21/8. Yeah. 21/8. 8/8 makes a whole. So 8/8 would be 1 whole. 16/8 would be 2 whole. That's all I have, 2 wholes. 16, it would leave 2 5/8. So how many 3/7 and 9/8? 2 and 5/8 of a 3/7, otherwise known as 21/8, otherwise known as 63/24. They're all correct. So practice the thinking behind this keep it, change it, flip it algorithm. I hope this helps.